Hello everybody. Today we're going to be taking a look at lesson 7-2. We're actually going to be spending 2 days on this. 7-2 takes a look at inverse functions and relations. And I'm actually going to be gone today and tomorrow. I'm at a training administration has sent me to. So if you have any questions or anything, feel free to email me. I will just be out of the building with some other teachers and such. So before we get into the inverse stuff, let's review a couple of words here. First of all, relation. We haven't seen this word since back in chapter 2. Okay, a relation is, very simply put, a set of ordered pairs. So any set of ordered pairs, sometimes they're just listed as points, sometimes they're represented as equations. You know, we've seen a lot of examples back in chapter 2. Then a function is a special type of relation. Okay, a function is a relation in which each element of the domain is paired with exactly one element in the range. And again, back in chapter 2, this basically means that the x's don't repeat. Okay, so that's what makes it a function. All right. Now, when we talk about an inverse relation or an inverse function, because remember, a function is just a special kind of relation, okay? What that means is the x and y values switch in the ordered pairs. Okay, so if we have a very basic example here, let's say we have a relation, I'll just use 1, 2, 3, 4, 5, 6. Okay, well, its inverse is just going to flip those. So instead of 1, 2, it'll be 2, 1. Instead of 3, 4, it'll be 4, 3. Instead of 5, 6, it'll be 6, 5. Okay, so you're just switching the order of the x and y values. Okay, pretty simple. Now, if we're looking at a function, okay, let's say a regular function, and then I'll compare that with an inverse function. Because we kind of already looked at ordered pairs. It's just a matter of, okay, well, how else is this going to look? Okay, so first of all, let's look at the function notation itself. So we all know function notation as being f of x. Okay, now when we denote an inverse function, we're going to go f to the negative 1 of x. And that doesn't mean you're going to raise anything to a negative power or anything like that. It just denotes that that's an inverse function. Okay, so don't think that we're going to be, you know, like using exponents and things like that, because that's not what that means. All right. As far as a point goes, well, we already kind of talked about that. Let's say we have some point a comma b. Well, its inverse, just like that above example, would be b comma a. Okay, so again, you're not changing any signs or anything like that. You're just flip-flopping the x and the y. Okay, if we look at like f of a, let's just say that equals b. Well, the inverse, since we're flipping, again, you're just flipping the x and the y. Okay, or in this case, the a and the b. Okay, So now let me give you some steps because we all know that, when we have equations, sometimes things get a little bit dicier. Okay, so let me go through some steps and then I'll show you some examples of finding an inverse when we are looking at some equations. Okay, so steps for finding an inverse function. And I think you'll get the hang of this pretty quickly because it's really not too challenging. You guys have done much more challenging things than this so far this year. Okay, so first of all, we are going to replace the f of x, that function notation, with y. Okay, so we're going to rewrite it as a y equals rather than an f of x equals. Okay, second step, switch the x and the y. Okay, so you literally will have an x in your equation. You're going to flip-flop that with the x and the y. Then with this new equation, you are going to solve for y. We've done that several times. And then finally, replace y with our new function notation, f to the negative 1 of x. Okay? So replace your f of x with y. Then you're going to switch the x and the y, and then solve for y. And then just replace that new y with your f to the negative 1 of x. Okay, let me show you how this works. So as far as directions, it'll just say something like find the inverse function. Okay, and then you'll be given a function. So here's our first one, f of x equals negative 3x. So let's start out with a simple one and we'll go right through these steps. Okay, so the first step is replace the f of x with y. Y equals negative 3x. Okay. Second step, we're going to switch the x and the y. So now I'm going to go x equals negative 3y. I literally flip-flopped the x and the y. Okay, now I'm going to solve this new equation for y. So in this case, looks like I'm just going to divide that over. And then just replace it with an f to the negative 1. So I'll write it over here. Okay, that's it. Not too bad. Okay, let's try another one. How about, here I'll use a g of x. Remember, you can use g's, you can use h's. F is just kind of our go-to. Okay? First step, y equals x plus 4. Second step, flip-flop. Third step, solve for y. So I'm going to subtract that over. Last step, put it back in function notation. So in this case, it's a g. Now, if you write f of x and it's supposed to be a g of x, I'm not going to mark it wrong. Don't worry. Okay, I know the f of x is kind of our go-to. Okay, a couple more here. I'll just kind of increase in difficulty as we go. Here's another f of x equals negative 2x minus 1. Okay. So y equals negative 2x minus 1. Flip the x and the y. So x equals negative 2y minus 1. Solve for y. So it looks like we're going to add a 1 first. And then divide by 2. And I'm just going to put this whole thing over 2. If you want to write it as x over negative 2 plus negative 1/2, if you want to do it that way, that's fine too. This is how I'm going to write it. And then finally, there it is, and you can leave it just like that. Again, if you want to break it up into separate fractions, that is fine. Okay, last one. g of x equals negative 2/3 x plus 1. And throw a fraction in there. Okay, so y equals negative 2/3 x plus 1. We're going to flip-flop. Solve. We're going to subtract that over. Okay, now remember when you have a fraction and you want to get rid of it, you're going to multiply by the reciprocal. So we're going to multiply by a negative 3/2. Okay, and then rewrite it. Now again, if you want to write that in a different way, like for example, if you want to write it as maybe like this, or if you want to distribute that in there, that's fine. I mean, they're all just different ways of writing the same thing. So any one of them is perfectly fine with me. Okay? All right, that's all we're going to do today. This is just the first half of 7-2. We will do the second half of 7-2 tomorrow. So now your assignment, it's also written on the sideboard. It's going to be on pages 395 to 396, numbers 10 through 27, but skip number 16. And then for numbers 19 through 27, it's going to tell you to graph. Don't do it. We're not going to look at the graphs today. Okay, so ignore that direction for 19 through 27. And then, so you have 10 through 27, skip 16, and then 47, 48, 49. There you go. Have at it.